Hello. In this video, I'd like to discuss how we can use measures of central tendency to make predictions about the shape of a distribution. When I talk about measures of central tendency, I'm talking about the mean and the median. In this Excel spreadsheet, I've selected data in such a way that it will create a symmetric distribution. You can see just by the values that I've chosen that this is going to be symmetric. You've got a middle characteristic value of 15 with about an equal distribution of values above and below it, or to the left and right. Now, if I were to create a histogram of this, you would see the symmetric nature of the distribution of values. So let's go ahead and do that by selecting Data and Data Analysis and Histogram. And I'm going to specify the input range, cells A1 through A11. I'm going to specify my class boundaries. That's cells C1 through C10. Oops. These class boundaries that I've chosen, I just chose in such a way that would give me that symmetric distribution. However, notice I am using a class width of 1. For my output range, I'm going to choose an empty cell here, cell E1. And I'm going to make sure that I select chart output so that I get a histogram. And then after I've input those values, I'm going to select OK and get this histogram. Now notice the histogram itself is a little rough because I do have just a limited amount of data, but you see the symmetric nature of the distribution of values. Let me redraw it on a blank piece of paper. So if I were to have now my axes here, right, then the distribution of scores would look like this. Right? It's a nice symmetric distribution. In other words, your hump is in the middle, and then if you were to separate that into halves, one half of the graph would be a mirror image of the other. As it turns out with symmetric distributions, these are unimodal, meaning the mean and the median coincide at the same value, or approximately the same value, because sometimes you'll calculate these and they'll just be a tiny bit off, and you just have to be able to gauge, how much off is, too much and how close is close enough. In this case, the way I've chosen the values, we're going to see that the mean and the median for this set of data is identical, and we can do that by generating the descriptive statistics. So we could create the mean and the median either separately or use the data analysis toolkit, which is what I'm going to use. So I select data analysis, descriptive statistics, and OK. My input range again were cells A1 through A11. My output range now for my descriptive statistics, I'm just going to click on this input box and then select a blank cell on my worksheet. And then I'm going to click Summary Statistics. And when I do that and resize these columns so I can read them, you'll see that for this problem, for my set of data, the mean is 15 and the median is 15. They coincide at the same value. So when you generate your summary statistics, if you notice that the mean and the median are equal to each other, then there's a likelihood that the distribution shape is going to be symmetric. Now, consider this. To my set of data that I already had, I'm going to include one more piece of data, this 1, a very, very small value. Now consider this. If this were a graph of my original data, and I included an additional value of 1, well, what would that do is it would stretch this left tail out, because now we would have a value of 1 with a frequency of 1. So it would elongate this left-sided tail. What that would do then is create this type of a distribution. What we would get now, if this were the axes, is a longer left tail with a hump of data towards the right, or larger values, right? Because we supplied a 1 here. The rest of our distribution is still out here, but now we just have a little bit of a longer left tail. And we can confirm that as well by generating the histogram for this data. And notice I've been a little bit more conservative now with my selection of class boundaries. So here we go. Data analysis, histogram. I'm going to select cells now, A1 through A12. My class boundaries are in cells C1 through C5. I'm still going to leave my output range in this new workbook under cell E1, and I want to make sure chart output is selected. And when I select OK, now I get this distribution. And notice, if we were to smooth fit a curve around this, notice how the left side here, the tail for the left side, is going to be longer than the right side. Here's my hump. Really, basically, these first, the original 10 values I had. But now, because of the 1, I get a little bit longer left tail. Now, what's going to happen now is that we're no longer going to have a mean and a median that coincide. When we talk about a symmetric distribution, we make the assumption, because we've seen it, that the mean and the median coincide at the same value. And remember, the median is resistant to extremely large values or extremely small values in your distribution. You get a better sense of middle position with the median than you do at the mean, because the mean is calculated. You use every single value to calculate the value of the mean. Therefore, with the inclusion of that smaller value of 1, the median is still going to be relatively in the middle of the hump. But what's going to happen now is this. The mean is going to get pulled away. It's going to get pulled away from the median. It's going to get pulled in the direction of that tail, in the direction of the left tail. In other words, the mean gets pulled to the left. Hence, this is what we call a skewed distribution, and specifically left skewed. And it's called left skewed because the mean gets skewed towards the left, away from the median. Another way that people will often at times remember, what skewing, what direction is the skewing, is by looking at the tail. But if you don't have a graph and all you have are the summary statistics, when you notice that the mean is less than the median, often at times you're dealing with a left skewed distribution of values. And we can verify that now by generating the summary statistics for this data. So we go to data analysis. We again pick our descriptive statistics. We are going to choose our input range of cells A1 through A12. I'm going to choose an output range somewhere on my graph. Let's just say here. And I'm going to make sure summary statistics are chosen. So when I generate those, notice what I get. My mean, 13.83333. The median is 15. And notice the mean is less than the median, which confirms, yeah, we are dealing possibly with something that's left skewed. Now, let's move on to the last example. Here is my original set of data, except now I've included a very large value, 30. Now, what's going to happen is this. We're going to have that original symmetric distribution for these first 10 values, but now we've included a value far to the right, which is going to elongate the right-sided tail. So let me create a new note here. And what we're going to get now is this. We're going to get a distribution with a hump towards the lower values, but a longer right-sided tail. Now, what we're going to predict happens is this. The median, again, is still going to be in the middle of the hump. Except now, because of the inclusion of the larger value, the mean is going to get pulled or skewed in that direction. In other words, now it's getting pulled to the right, or the median is going to be less than the mean. Let's see what happens here when we generate our statistics and also the histogram. So I go to data analysis, histogram. I'm going to select the proper cells here of A1 through A12. My bin range, C1 through C5. My output range is going to be E1, which is already selected there. And I'm going to make sure I get a chart output. And what you'll see is, yeah, the hump of my data is towards the low values that are displaying with a longer right-sided tail. Right? Let's see what happens. What we're saying is this. We think that the mean is going to get pulled in the direction of that large value 30. It's going to get pulled to the right of the median, sorry. This mean is going to get pulled to the right of the median. Notice how it moved to the right. Whereas when we had a symmetric distribution, they coincided. So let's generate the descriptive statistics and see what goes on now. So we choose descriptive statistics, again, selecting the proper input data values, A1 through A12. My output range now, I'm going to select a cell that's doesn't have anything on it, like C11. I'm going to make sure summary statistics are chosen and enter. And what we see is this. Our mean is now 16.25. Our median is still 15. So observe, yeah, the median of 15 is less than the new mean of 16.25. And that's because that value of 30 has pulled the mean in its direction towards the right. Hence we call this a right skewed distribution. Now, one more thing I wanted to point out in Excel. When you generate these descriptive statistics, notice it gives you a measure of skewness. For this symmetric data, when all I had were values from 10 to 20, notice that the skewness was listed at 0. And 0 is a nice number because it's neither positive nor negative, right? So it's not skewed to the left, negative, or to the right, positive. When you're dealing with left skewed data, notice that the skewness is negative, negatively skewed to the left. Or when we were dealing with this data where we included the 30, we got a positive skewness, positive skewed to the right. And that's how we use the descriptive statistics of the mean and the median to predict the shape of the distribution in terms of symmetry and skewness.